So Aggelos, thank you very much for joining us today on the show. Let's start with a really straightforward question. We talk about cryptocurrency, but you've been working in cryptography since the mid-90s. What is cryptography?
Cryptography, first of all, has been my passion personally. I started working on this as I was a young student at the university. This was something very inspiring to discover this area. It was much less known at that time compared to how popular it is today. And certainly things were very different. Then in the mid-90s, the internet itself, even though functional, was nowhere near as popular as it is today. It was something that you would have access to if you were working in a lab or in university, and there were people that had access to in some specific ways via these services like the American Online Service and others. So it was a very different time, and cryptography as a discipline, especially its modern form, has been, of course, driven by the internet and the realization that if we want to take advantage of the internet in its full, if you want, capacity, we'll have to develop ways for people to have secure and reliable communications and exchanges of information over the internet, and cryptography would be an integral part of that. So modern cryptography is a scientific domain. It's mostly part of computer science and is also touching on math and electrical engineering and physics, of course, but still I would consider this to be a core computer science field in the way that it has developed today. So as an area of research, I think we can trace it back to the pioneering work of a number of people in the 70s, including Ralph Merkle, Adi Shamir, Ron Reversed, Whit Diffie, and Martin Hellman. These are the pioneers of the 70s that did major advances in cryptography that really shaped the field as we know it today. And actually, many of the things they did, we still use them very widely. And as a scientific discipline, I think its birth should come with the creation of the International Association for Cryptologic Research, which was in the early 80s. That was also another very interesting moment because it basically said that cryptography should have its own home, separate from other areas in computer science, and not actually directly associated with, at the time, the big associations for computing research, which were the ACM and the IEEE. So the IACR basically has been the home for cryptography for all the decades till today, and those people that, including myself, that did research, they in cryptography, they aspire to present their work and communicate advances in cryptography in these venues. Now, this gives you a little bit of the sort of background, like how cryptography came about as a scientific field. Now, what is cryptography, though? I think that's also something important to clarify. So cryptography, if I was to state it in one sentence, it's a science that aims to organize digital systems so that trust is distributed across their components in such a way so that the system's susceptibility to attacks is minimized. So that's what cryptography tries to do. It's like a way to design systems so that trust is redistributed to their components in some optimal fashion with respect to a class of attacks that we are particularly interested in to mitigate. And there are two important elements in that process. So first of all is that computational hardness will play a role. So the concept of computational hardness is, if you want, one of the most central concepts in computer science. It's also the hallmark of the most important computer science question right now from the theoretical perspective, which is the famous P equals NP question. And because this is a question that is exactly at the heart of computational hardness, like what is computational hardness? And in particular, it asks this question in the context of these two important classes of problems in computer science. And cryptography has this very interesting role in that context. It tries to mold computational hardness into a defense mechanism. So, and it tries to do that with respect to not just a handful of attacks, but to large classes of attacks, which are well defined in a computational model. So this gives like a bird's eye view of what, if you want, like what cryptography is about as a scientific discipline.
So a significant heritage, I suppose, in cryptography, despite the relatively recent arrival in cryptocurrencies. But where are we as an industry? We are very early, but we're evolving, we're maturing. There's a similar maturation happening around the application of core research into crypto projects. What's your sense of the current state of thinking there?
Well, it's certainly better compared to a few years ago, when basically input-output was the only company that was really doing it. So I was very glad to see other projects taking a similar approach to the one we take. But it's still like just a handful of projects that really engage in it. It's not very surprising. I guess one reason is that it's, first of all, doing research in cryptography and more broadly the other areas that touch on the cryptocurrency space, such as game theory, economics, and so forth, is very hard. And at the same time, the industry, so to speak, is still quite not mature enough, if you want, to properly price projects correctly. So you can easily get away with not doing much research and focusing on marketing and or some specific application domain that people are interested in at that particular time. So you can still see projects that get a lot of mileage without necessarily investing much effort in thinking, planning, and designing what they do. But I just think that this is just a matter of time. Compared, let's say, to a few years ago, I think the space has already matured much more, and this trend is definitely going to continue in the near future.
So maybe tell us a little bit about Input-Output's approach to research in the context of the software development organization as well.
So Input-Output research does basically engages in all areas related to distributed ledger technology, and in a first and principled manner. I think it's important just to focus a little bit on how this works, because I think this just in itself needs to be appreciated. So when you go about designing a system in such a first principled manner way, and you not just produce let's say a blog post or a design document that says how the system will be, but you try to articulate the system in the context of computer science research and cryptography in particular, you have to present the system in the context of the research domain where it belongs. You have to explain why the system has the benefits that it claims it has, what is the state of the art, in what way the state of the art is lacking, and what is exactly the problem that the system that is proposed is solving. And there is actually a lot of benefits in taking such a first principled approach. While it may seem at first that it takes longer, in fact, there's many examples where this helped us to arrive faster in certain desirable outcomes. And I might just give you one example of that, because this is one that I was just thinking quite recently. So a lot of people right now are talking about Ethereum and EIP 1559. This is like a major advance for Ethereum. So what's the main feature that people are talking about? So they're talking about, of course, fees. And traditionally in Ethereum, following Bitcoin, the fees of a block go to the miner that issues the block. But what happens with this new proposal, EIP 159, the fees, there's going to be a base fee that's going to be burned. And what's the main difference here is that when a fee of a transaction is being burned, this potentially benefits all the Ether stakeholders because it makes a slight reduction on the supply, the existing supply of Ether. Now, what I haven't seen being discussed much, actually, when you talk about, when you think about Cardano, is actually that Cardano has been doing this since the very beginning, and in a much more sophisticated manner, and without burning. So how does it work? So fees in Cardano do not go to the miner, but they are placed in a reward pool that is then equitably distributed to the ADA stakeholders that participate in staking, all of them. And even more so you can see the parallel immediately, right? Fees are benefiting everyone, but actually in a much more even sophisticated manner, because Cardano's reward mechanism is going to exclude from rewards those stakeholders that do not contribute to the system. So those stakeholders that do not contribute to the security of the system will not benefit from a particular fee. So, and now you might ask, like, well, and by the way, I should say, like, this is something that is not even discussed. I haven't seen this being discussed much. For example, I certainly haven't seen it being discussed this in the context of these developments in Ethereum, despite the fact that this was a day one feature for Cardano. So how did we arrive? You might ask, how did we arrive to such a sophisticated mechanism that also we haven't even particularly celebrated either? And this was actually first principles. So when designing the original Ouroboros paper, the protocol as well as the paper itself, and when we were writing it, we were trying to prove some theorems. Some of these theorems were about economic equilibria in the protocol. And when I was organizing the proof around the protocol being an equilibrium in a certain setting, the only way that you could get this mathematical proof to go through was if you would adopt such an organization of the rewards in this epoch-based fashion that Cardano does it. So here you would see an example that the math, just because of the fact that you try to achieve certain high-level properties that are important, the math themselves demand basically certain things in the design. And then by following them, you can arrive at this particular development. I mean, I should say, like as I say to my students often, one has listened to the mathematics. If you're able to tell them what is the problem and articulate the problem in the right language, they will tell you the solution if you're able to listen.
So how has the input-output team grown and developed its approach and its processes over the past year or two?
So the general input-output team, of course, has grown a lot over the last few years. The general approach, especially in research, has not changed fundamentally. We still strive for high-impact, top-quality research outputs, which are disseminated very widely in the top venues for research in the area of distributed ledgers, cryptography, as well as financial technologies. Now, Perhaps I should say a couple of words just to remind our listeners about how the input-output research operates. So we do have a three-pronged approach. First of all, we do have our in-house researchers. These are full-time employees at input-output. We have embedded research, which are people that are working at university labs, which are funded by IOHK. And finally, we have external collaborators, external research projects, which is basically outsourcing the research, some specific problems, some specific research problems to partners with contracts which are very specific in terms of time and deliverables. So this three-pronged approach all is coming to work together and deliver the research output that you've seen that the company has been producing during these years. Now, I want to emphasize a bit also the positions of research fellow within input-output. These are extremely selective posts. Someone has to have published already for a few years post their PhD in the very top venues for their respective area in order to be considered for a research fellow position. And I have to say I'm really blessed to be able to work with some really amazing people that serve as research fellows at input-output.
And you and your team, of course, have delivered and contributed a significant volume of research, which we'll provide a link to everybody to take a deeper dive. Perhaps you can just highlight perhaps a few of the more recent pieces of research that you'd like people to better understand and know about.
So in the last few months, we either had published or accepted for publication a few papers that I'm very excited about, so I might tell you a bit about them. The first one is Hydra, that appeared in Financial Cryptography and Data Security 2021 earlier this year. This is just the first installment of the Hydra protocol suite. Specifically, what we published was what we call the head protocol. And this covers the use case where you have a layer 2 protocol that is maintained by a set of entities that are online and are interested in advancing extremely fast at the physical limits of the underlying network, the state or a part of the state of the main chain protocol. Now, a unique characteristic of Hydra is that it achieves that in an isomorphic sense. Isomorphic is a Greek word which means equal form, isomorphic. The key point behind this concept is that the scripting language that is available at layer 2 is identical to the one that runs on the main chain. Thus, if someone wants to run a distributed application on top of this layer 2, they don't have to make any specific or special adjustment for having their smart contract operate on Hydra. So this distinguishes this layer 2 approach from, say, others, for instance, Lightning, which is a layer 2 solution on top of Bitcoin, that do not respect the underlying scripting language. So an application, for instance, running on top of Lightning will have to recognize the way Lightning works. Now, there's more coming up with respect to Hydra. We are working now on the Hydra tail protocol, which will also in itself will come in a couple of installments. This covers the other use case, which deals with the setting of a layer 2 that does not have the same online requirements for all participants. In particular, what we're focusing on is a setting where one participant is highly available while the remaining of the participants may not be and only intermittently might connect to the system. So more updates on these new editions of the Hydra protocol covering these other use cases will be coming up very soon, as we just finished the very first version of that protocol, focusing on payments. Now, another paper I should mention that I'm very excited about is Ouroboros Chronos, which was accepted at Eurocrypt 2021, and actually it was due to be presented last month. Nevertheless, Eurocrypt this year moved to the bit later in the year, in October, due to the pandemic. So there is a hope that possibly in October it will be more feasible for people to travel, and it is expected that the conference might take in person, or at least partially in person and partially online. This has still to be determined. In any case, this is a very exciting output, not only because Eurocrypt is one of the two top conferences in cryptologic research, but also because the result itself demonstrated something that initially, when I started working on these questions many years ago, seemed exceptionally hard. The question is whether to offer a proof-of-stake blockchain discipline, do you need to have an agreed concept of time between the participants? And this was something that seemed essential and was actually used in all these dynamic proof-of-stake blockchain protocols. But nevertheless, with Ouroboros Chronos, we demonstrated that this is not needed. So the Ouroboros Chronos protocol actually demonstrates how it is possible, based on ad hoc and dynamic participation, to build a global concept of time and export it not only to the participants of the protocol, but also to any application that is running on top of the ledger. That means that any dependency, any external dependency on a global clock is removed, and in this sense, the protocol becomes its own timekeeper.
So those are the recently published papers. What else is the team working on at the moment that you feel is particularly notable?
So, of course, I mentioned the upcoming work on the Hydra tail protocol, which continues very intensely during the next month. Something else I'm very excited about is the work that we have been doing during the last few months and will be intensifying over the next few months and perhaps the remaining of the year, is on the concept of transaction fees. This research thread started already earlier this year with a blog post that I wrote on bubble fees. This is the concept that allows ADA stakeholders to not only utilize user-defined tokens, but also pay transactions using SATS tokens. So what happened there in terms of process is that the blog post first presented the idea. We collected some feedback in this manner. When we worked on the paper, I'm very happy now to say that the paper is online, is already as a technical report, and also in the process of being submitted for academic peer review. Very soon we're also going to be going to the stage of looking into a prototype for that system. Now, following up and complementary to that work is something that we have already been looking for some time, but will be intensifying over the summer and the remaining of the year, is the concept of stable fees. Stable fees is addressing the problem of having predictable and fair transaction fees for the whole community of stakeholders in a system like Cardano. Now, the problem of fees is a very crucial one, and of course widely recognized as an essential for a successful blockchain system. What we want to achieve with this research is, first of all, predictability. So in other words, if you are a heavy transaction issuer, you should be able to plan ahead and, depending on your transaction needs, have the resources that are required for you to be able to engage with the system. So we don't want, and I should stress, even at layer 1, we do not want transaction issuers to have surprises with what they may encounter when they will be engaging with the system. Now, at the same time, the fees should be fair and consistent with the service and the effort that the system requires for its maintenance. So it should not be possible, in other words, for fees to be manipulated or being placed at values which are not consistent with the utility that the system offers. Now, these are particularly fascinating and interesting questions. This is a really difficult problem, and I'm very excited to now lead this, the team towards making some very interesting advances in this direction, some of which, a glimpse of which, I've detailed in a recent blog post on stable fees that came almost a week ago. Of course, this is just one of the many active research threads right now within input-output. There is many more to mention, but I think that going through them is in itself another, perhaps much longer discussion, but there will be many of them that you will be seeing coming up. Perhaps, like, just to pick only one, is our work for Voltaire and the governance system, which requires very interesting research advances, both in terms of game theory as well as in terms of the cryptographic mechanism that supports voting.
So, Aggelos, of course, the area of rewards, of fees, of pledge, these are all pretty hot topics within the community. And of course, you and your team have been very heavily involved in a lot of this. Do you have any updates in this area?
Yeah, in the last few months, actually, we took a deep dive, investigated how the incentive mechanism has been absorbed by the community and how people are engaging with it. There's many interesting findings, actually, that we will be sharing them soon, as well as slight adjustments to the system that improve the way the mechanism operates. Now, one has to realize, team, that this is a difficult problem. Real decentralization and security is not about just counting the number of validators or the size of the market cap. I mean, we are in for the real thing. Like, we really want a resilient, decentralized system. So given the challenge, like the analysis we did on how the system is, I'm quite happy with where the system right now. There's many truly independent pools and a lot of meaningful discussion in the community about how staking should work. But there's also things that we would like to adjust and make better. So the popularity of ADA at the same time and the expansion of the user base has given also little opportunity to new people to familiarize with the mechanism. Something actually that was interesting to observe is how suboptimal people make choices about delegation. There's also many suboptimal pool offerings, but suboptimal delegation is actually something that we widely observed. So basically, what I mean by suboptimal is people not making the best choice to maximize their rewards. And this actually creates a lot of problems in the system. Just to explain that the theoretical equilibrium with any set of pools that exist, there is an expected ideal return on ADA. You can think of this as an ROA metric. So many delegators do accept much worse ROA such returns on their ADA delegation to a pool. So if you want to think about it like this, they don't play the staking game in the optimal way to maximize their returns. And actually this gives a lot of opportunity to pool operators, to some pool operators, to take advantage of that. So what we see, for example, as a strategy that takes advantage of this is operators who create multiple pools. And creating multiple pools gives only marginal benefit when delegators play optimally. So basically when the whole system is at equilibrium. But when the system is not close to equilibrium, this behavior can be quite beneficial to those who engage with it. And this is actually bad for the system. Multi-pool operators squash small SPOs and leave them without a chance to contribute to the system. And interestingly, in a typical case, they also deny an amount of rewards from their own delegates. So raising awareness of these issues and creating a more engaged delegation community is something that we're continuously working on. So what the community should expect, there's going to be very soon some immediate adjustments to the way that people engage with the mechanism so that they give a better experience and a better understanding of how the system works. And a bit further down the line, we will also be doing some careful surgical adjustments to the rewards mechanism itself so that the whole system efficiency from an economics perspective is maximized.
Another topic which people may have heard a little bit about is the Mithril Lite client project. Perhaps you can tell us just a little bit about that and why that matters.
Yeah, so Mithril is an important set of cryptographic methods that we're investigating now that are around building light clients. So from a cryptographic perspective, if I may start with that, we're focusing on this primitive of succinct non-interactive arguments of knowledge. And sometimes people talk about them as snarks in the greater cryptographic community. So a snark is a cryptographic primitive that enables to create a very short proof about a certain statement. Now, the key problem we want to solve is how to create a very short certificate that the majority of a stakeholder population stands behind. Now, what's the benefit of such a mechanism is that you can allow the whole stakeholder community, for example in Cardano, to create a very short statement and say, that's the current state of the system. Furthermore, you can even create a chain of such statements. So you can actually have a statement that says, well, at present, this is the current stakeholder community and stands behind that message, and that's the current state of the system. And then you can present the next statement and the next. And these statements are very short. So the resulting system, or the resulting outcome from this process is that you end up with a certified state of the system, which is completely trustless. You don't have to trust anybody because it's the whole community behind it, but you can validate it extremely fast. So the benefit of this, of course, as you understand, is that someone can connect to the blockchain much faster compared to what's happening right now. So we have already completed like a first round of research in these techniques, and there is a technical report that's coming out. And there is a paper which is submitted for peer review, and what the community can expect very soon is to start seeing a prototype being tested, as well as eventually the system being deployed as part of Cardano.
So Aggelos, obviously we're very busy in terms of the rollout and the road to Alonso right now, but what's your summer looking like?
All right, so it's a very busy summer for research as well. There's a lot of research threads that we're very actively pursuing. Maybe I'll just say a few words about one. So this relates to Ouroboros Omega, and it's a particular part of Ouroboros Omega. Maybe just one word about Omega. So Omega is the project that takes all the research we have done in Ouroboros over the last few years and converges everything to a single protocol, which is going to be a layer 1, highly scalable, efficient protocol that could be used in the context of Cardano. But now specifically, within that context, what we're looking at is relates to network split safety. So just a couple of words to give a bit of the motivation that we have behind looking at this question. If you look at consensus from first principles, as a problem, it's epitomized by two properties, consistency and liveness. And these two properties, which of course ideally you want to have them together, obviously, it doesn't make sense to have the one without the other, when the system goes to extreme conditions, at least one of them has to fail. It's impossible to preserve both consistency and liveness. And when you design a consensus protocol, you have, or at least that's the conventional wisdom, so to speak, you have to decide what's one to give up. So for instance, Bitcoin is liveness favoring, the original Ouroboros protocol is also liveness favoring, but other classical consensus protocols are consistency favoring. So since mathematically you cannot have both, you can say, well, that's the end of the story. But there is a very interesting point here that, well, okay, one of the properties has to go if you are at extreme conditions. But the question is, can this be a decision that is driven by the user and not the protocol itself? So basically, this can be a quite exciting aspect because depending on the threat model that every user prefers, they can choose which property at disaster moments of the system, they can choose to forego. So depending on the particular use case that a certain user of the protocol is interested in, they can choose to forego a different property. And some users may choose to forego consistency, and others may choose to forego liveness. So this is very natural, and it makes the system much more flexible compared to, say, any consensus protocol that, by default chooses one of the two properties. So I'm very excited to go deep right now over the summer in one of our research threads with Ouroboros research on that, and I'm actually thinking that hopefully by the end of the summer we'll have this done, and this is going to be one of the key final points in our Ouroboros Omega development, which I would consider to be like one of the crowning jewels of our research department over all these years, like finally giving this proof-of-stake protocol that basically solves every single problem that we could have imagined when we started this road towards understanding this class of protocols.
Aggelos, thank you very much.
Thanks, Tim.